So if we look at this, we've got the formula, perimeter equals 2 times the length plus 2 times the width. We know the perimeter is 150, so I can put 150 in there for P. But we still at this point have two variables, L and W. So we have to get rid of one of them. So there's got to be a relationship somewhere relating the two of those to each other. So we've got the length is 4 times the width, which is telling us that L is equal to 4W. So now we will rewrite this equation here with 4W in there in place of L. So 150 equals, instead of 2L, it's going to be 2 times 4W plus 2W. So now then we can go ahead and try to solve this. Before we solve, we have to simplify everything we can on each side. So on the right side, what can we do to simplify? Well, 2 times 4W is 8W. Is there anything else we can still simplify or combine? 8W and 2W makes 10W. So 150 equals 10W, and then there you go. Now we are down, and everything's simplified. The variable only appears once, so now we can solve it. We're going to divide by 10. 15 equals W. Now that's part of our answer. W equals 15. But it asks for both length and width, so we have to make sure we go, the length is 4 times W, so 4 times 15 gives us the 60 for the length. And technically the units should be inches. Any questions on solving that? Okay. Well, we're going to look today at a unique type of problem called a mixture problem. When we're dealing with mixtures, there's something called a concentration. Almost every mixture you run into has at least 2 pieces, but has 2 pieces where one of the pieces is an active ingredient. And the other ingredient, the technical term is a diluent. It's basically a carrier, a filler. If you think of iodine, iodine is an example. There's almost any solution can be thought of this. But iodine, you almost never find pure iodine. Most iodine you find comes in like a 3 or a 4% solution. It's been diluted with an inactive ingredient that doesn't do anything. Peroxide, hydrogen peroxide. Most of what you find there is 2 or 3%. If you really search, you can find maybe a 10% solution. You go through Scientific Supply, you can maybe get a 30% solution. But hydrogen peroxide, again, you have the hydrogen peroxide itself as the active ingredient, but it's diluted with mostly water. So the amount of that active ingredient is equal to the concentration times the total amount. For example, let's say we have 300 milliliters of 12% iodine, it's implied iodine in water solution. What that means is we have 12% is it represents our concentration, but we usually represent the concentration as a decimal. So what is 12% as a decimal? 0.12, very good. Times the total amount is 300 milliliters. If I multiply that out, that is 36 milliliters. That is the amount of iodine in that solution. Does that make sense? Similar to that, we might have 50 milligrams of 8% saltwater solution. How much salt is in that solution? What's my concentration? 8% becomes 0.08 times 50 milligrams. 0.08 times 50 is 4 milligrams. The reason we're looking at this is we're going to talk today about mixing solutions. In automotive, this happens a lot with mixing, antifreeze, or if you have dealing with a two-cycle engine, which I know is not automotive, but the mechanical side of it, dealing with two-cycle engines where you have oil gas mixtures and stuff like that. You can deal with fuel and additive mixtures and other things that have to be set in the automotive trade. And in dairy, there's actually a lot of places where solutions come in. You deal with some of your rinse and dip solutions, some of your acid cleaners for the pipelines and stuff like that need to be diluted down. You can end up, mixing different concentrations of solutions in a lot of ways. So let's take a look. And of course, in all your medical treatments for the animals deal with solutions and concentrations. So let's take a look if we mix 200 milliliters of 30% solution with 300 milliliters of 45% solution. Let's find the final concentration of this. Well, what we have to look for in these equations, when we're doing word problems, we have to look for two things that have to stay constant, things that have to stay equal. And there's a couple of ways that works out. One possibility is you can have two numbers, two values that have to equal each other. A equals B. So if you can find two things that have to equal each other, you're good to go. Another possibility is you might have two things that have to add up to make a total, which is what this one's going to be. And then a third possibility, you might have two things that subtract to make a difference. Well, in this one, we have two things that add up to make a total. We have the 200 milliliters of 30% solution, 300 milliliters of 45% solution that are going to add up to make our total solution. But what really is adding up is the milligrams of whatever or milliliters of whatever our active ingredient is in each of those inputs. So for the first input, it's the 30% solution. We're going to combine that with what percent? 45% to get, we don't know what percent. We're trying to find that percent. Do we know the amount of each? Yeah, how much 30%? 200 milliliters. Do I know how much 45%? How much? 300 milliliters. Do we know how much total we're going to have? Yeah. We can just add 200 plus 300 gives us, we're going to have 500 total. So now we can write our equation. The amount of active ingredient in the first one is that concentration. 30% would be 0.3 as a decimal, times 200. The amount in the second one, 45% is 0.45 as a decimal, times that total amount of 300 is going to equal, I'm going to use X here because that's what I'm trying to find is the concentration, times 500. Point 0.3 times 200 is 60. 0.45 times 300 is 135. Equals, I'm going to do X times 500 is 500X. Now, I have to combine 60 and 135 is 195. Equals 500X. And finally, I'm going to divide by the 500. I get 195 divided by 500 is 0.39. So it ends up being 39%. Now, typically, we are not randomly mixing different solutions and hoping, trying to see what we get for a final concentration. Typically, we have a desired concentration that we are shooting for. So usually we'd end up with something like this. How much 42% solution should you mix with 120 milliliters of 30% solution? Helps with spell it right. Solution to create a 34% solution. So here's the same type of deal. We are mixing percents. What are the 2% we are mixing? 42 and 30. 42%. We're mixing that with 30%, trying to create 34%. This time we know the percent, and usually we do. We know what percent we want the final result to be. What do we know for the volumes that we were mixing, or the amounts that we were mixing? 120 goes with which one? Yes, 120 of the 30, so it's 120 milliliters. I'm trying to find how much of the 42%. I'm going to let that amount be X. How much of the 34% are we going to create then? Perfect. Yeah, up here, we did 200 plus 300 gives us 500. Down here is the same thing. X plus 120 is X plus 120. So now 42% is 0.42 times X, plus 30% is 0.3 times 120 equals 34% is 0.34 times X plus 120. Well, 0.42X isn't going to change. 0.3 times 120 is 36. What do we have to do over here? We're going to have to multiply through by the 0.34. What's 0.34 times X? 0.34X. 0.34 times 120. 40.8. Now what? Just figure it out. So where do we start to just figure it out? Okay. Yeah, we see that there is still an X on each side, so we get rid of one of them. So we're going to subtract the smaller one, which is the 0.34x. So that is 0.08x plus 36 equals 40.8. Then subtract the 36. 0.08x equals 4.8. And then divide by 0.08. X equals 60. 60 what? Milliliters, exactly. So you would add 60 milliliters of the 42% to the 120 milliliters of 30% to create a 34% solution. Let's say you have a 12-quart cooling system. That currently tests at 40%. You need 60% to handle 40% antifreeze. I should have said that. Currently tests at 40% isopropyl alcohol or antifreeze. You need it at 60% to withstand your minimum temperatures. So the question is, how much should you drain and replace with pure IA, is just isopropyl alcohol, in order to get to that 60%? So what two things are we mixing here? So you have pure with already mixed. Your pure is what percent? 100%. And you're mixing with the already mixed, which is the 40%. And you want to get 60%. The only amount we know here right now is 12 quarts. What is that really describing? Now, it's easy to say it's describing the 40%, but it's describing how much of the 40% we have right now. It doesn't describe how much we're going to keep, right? In the end, we hope to have 12 quarts of what? The 60%. So that's really the 12 quarts. Which amount are we trying to find? The amount of the 100% or the amount of the 40%? Well, if we drain it out and replace it with pure antifreeze, the amount we replace is the amount of the 100%. Okay? That's going to be our X. That makes the 40% 12 minus X. If we drain out X, what's going to be left of the 40% is the full amount minus the amount we drain out. So 100% as a decimal is 1. So 1 times X plus 40% as a decimal is 0.4 times that amount of 12 minus X equals 60% will be 0.6 times 12. 1x is still just 1x or just x plus. We distribute the 0.4. 0.4 times 12 is 4.8. 0.4 times negative x is a negative 0.4x. equals 0.6 times 12 is 7.2. And then we're going to combine our x. We see that there's an x that appears twice. Both are on the same side. So I'm going to combine 1x basically with a negative 0.4x gives us 0.6x, still plus the 4.8 equals 7.2. And then we'll subtract 4.8. So 0.6x equals 2.4. And then divide by 0.6. X equals 4. So what that's saying is you should drain 4 quarts out of the system and replace that with the pure antifreeze, pure isopropyl alcohol. And it'll should bring you up to 60%. Any questions on that one? That one's on the more difficult end of the spectrum. How much 13% solution should you mix with 180 milliliters of 19% solution to create 15% solution? What's that? Okay, that's a good observation. Since we're going to end up with something closer to the 13, the amount of the 13 should be bigger than the amount of the 19. It's going to take more of it because you want to get closer to it. What percents are we combining here? We're combining the 13% and the 19%. And we want to get 15%. Very good. Now, how much of the 13% do we have? That's what we're looking for. How much of the 19% do we have? 180 milliliters. So how much 15% will we have? X plus 180. So our equation here is going to become 0.13x plus 0.19 times 180 equals 0.15 times x plus 180. Now we're just going to solve for x. 0.13x plus 0.19 times 180 is, what is that, 34.1? That's not right. 34.2, I think. Good. 0.5 times x, or 0.15 times x is 0.15x. 0.15 times 180 is 27. Now we'll see that the x still appears twice. So we're going to combine those. I'm going to subtract 0.13 x from both sides. So I've got 34.2 equals 0.02x plus 27. And then subtract 27. 7.2 equals 0.02x. And done. Divide by 0.02. Which is going to give us 360 equals x. So it's 360 milliliters. What do you think? Okay. So last time I had you work on page 260, exercise 6.5. Make sure you're still spending the time on those. If you didn't get them done, make sure you're still working on them. Then I'm going to add to it these mixture problems on page 264, exercise 6.6. Now, a couple of weeks ago, I offered you guys some extra credit. One of the extra credits looks something like this. I started out with x equals 1. I multiplied both sides by x to get x squared equals x. I subtracted 1 from each side to get x squared minus 1 equals x minus 1. I split that x squared minus 1 into x plus 1 times x minus 1 equals x minus 1. And then I divided both sides by x minus 1. X minus 1 divided by itself is 1. Same here, that's 1, so this is just x plus 1. And then I subtracted 1 to get x equals 0. But we started out with x equals 1. So if x equals 1 and x equals 0, then 1 must equal 0. Did anybody find the flaw in that? I mean, hopefully that's not correct, that 1 doesn't equal 0, because if it is, that means our whole theory of numbers is kind of worthless. Well, I did this piece here in red for a reason. I divided by x minus 1. What does x equal? 1. So 1 minus 1 is 0. Can we divide by 0? No, if we divide by 0, your calculator says error. If we allow ourselves to divide by 0, the value of a number becomes worthless. So that's an example of some weird things that can happen if you allow yourself to divide by 0. Now, another one I gave you was this: 0.9 repeating plus what number equals 1? Or 0.9 repeating equals 1, one of the two, depending on how I worded it. What number can we add to 0.9 repeating to make it equal 1? Well, 0.9 repeating is 0.999999, right? Well, adding to that to make it equal 1, we just have to get a 1 way out here, and it's going to carry all the way up to the 9s, right? So it'd be 0.000000 followed by a 1, right? How many zeros do we have to have? Well, how many 9s are up here? It goes on forever, right? There's infinitely many 9s, which means there has to be an infinite number of zeros here followed by a 1. Does that make sense? Not really, right? There's an infinite number of zeros. Does the 1 ever happen? No. What do we add to 0.9 repeating to make it equal 1? We add 0 to it. 0.9 repeating is defined to be equal to 1. Let me show you. If I let x equal 0.9 repeating, I think we looked at this just a little bit, taking those repeating decimals and turning them into fractions. 10x is going to then be 9.9 repeating, correct? If I multiply both sides by 10. And now what I'm going to do is I'm going to subtract 0.9 repeating here so that the repeating cancels out. That leaves me with 9. Well, on the other side, I'm going to subtract the same thing, only since x equals that, I'm going to subtract x over there. 10x divided by, or 10x minus 1x is 9x. If I divide by 9, x equals 1. So here's a case where x equals 0.9 repeating, and then I later get x equals 1, and it is true. 0.9 repeating does equal 1. They have the same value. Any questions? I said those are just the extra credit. Like I said, I'll let you guys have the last 10 minutes here to work on those couple of pages. Make sure you get good with the word problems. Coming up on the test, which will be Thursday, there will be a mixture, at least one mixture problem on it. So make sure you're good with those.